University. I am glad to present you my work entitled by of development of a new lower cost tube method for the screening of antibiotic residue in meat. Problematics. Currently, the use of antibiotic is common in animal production, systematically for chicken farming, and for preventive and therapeutic purpose for ovine and ovine farming. So the indirect use of these antibiotics leads to the presence of the residue in meat at a level exceeding MRL, or maximal residue limits. The analysis of this food is therefore necessary in order to guarantee their quality or their conformity. Microbiological methods or techniques are widely used for detecting antibiotic residue in meat. Some of these methods are named screening methods, others such as pre-test, others are named confirmation methods such as four-plate method. These methods are characterized by the high cost, so we must provide, or it's necessary to provide, a simple, sensitive, and inexpensive screening method. The PRIMI-test, the principle of the PRIMI-test consists of the content of a multisensitive strain is Bacillus stereothermophilus with a meat juice in a colored medium. After incubation, if the medium remain purple, the sample is considered as positive. If the medium begin yellow, the sample is considered as negative. The confirmation method consists to contact strains known for their sensitivity to defined antibiotic families at considered pH with a meat disc. After incubation, we observe the annular zone of inhibition. If it is more than 2 millimeters, the sample is considered as positive. If it is less than 2 millimeters, the sample is considered as negative. If the inhibition zone of the control is more than 3 millimeters. Our alternative method is we have developed our alternative method for different steps. The first step is a single method plate development. The principle is to observe the annular zone inhibition of a multisensitive strain in a single plate containing a medium. The principal tested strain are Staphylococcus aureus, Bacillus stereothermophilus, and Micrococcus luteus, which is the most sensitive strain. And we have tested different two media, Müller-Hinton and soya agar. To develop our alternative method, we have analyzed 61 samples, 31 chicken and 30 bovine. These samples are firstly analyzed with reference method. PRIMI-test permits to have 18 positive samples and 43 negative samples. The confirmation method permits to have the same number of positive, but we have 3 doubtful among the 43 negative samples. Permit me to present you some detailed results. For example, for white meats, we have 40% of samples which are contaminated by beta-lactams, 80% are contaminated by sulfonamide, 80% are contaminated by aminosid, and 15% are contaminated by quinolone. For the same category of meat, if we study the association, 50% of samples are contaminated by one category of antibiotic, 30% are contaminated by an association of two antibiotics, and 80% are contaminated by an association of 4 antibiotics. In our alternative methods, we have analyzed the same samples in a single plate. Among the 18 positive samples, we have detected 15 samples by Bacillus thermophilus inoculated with Müller-Hinton. In soya agar, we have detected 10 positive samples. We have also detected 10 positive samples in Müller-Hinton inoculated by Staphylococcus aureus, and all samples are detected as negative in soya agar. So the most sensitive sample is Müller-Hinton. When we combine this medium with the most sensitive strain, which is Micrococcus luteus, all samples are detected as positives. To exclude the presence of false positive, we have analyzed the 40 negative samples and the 3 doubtful samples with the 3 negative control samples. All these tested samples were revealed as negative. The second step of our alternative methods is to test it in tube. It's a miniaturized tube test which consists of mixing a strain known for its sensitivity, which is the optimal strain, which is Micrococcus luteus, with a culture media, which is Müller-Hinton, containing a colorant indicated. So when we put our sample, which is meat juice, if the medium color change, we consider that our sample is negative. If we have an absence of color change, our sample is considered as positive. Several parameters are studied. Some of them are medium-related parameters, such as the nature of color indicated. Here we have optimized 3 color indicated, and the minimal bacterial inoculum giving a clear change in the medium, and the incubation time giving a clear change in the medium. We have also sample-related parameters, such as properties which is related of meat juice and its volume. Among the 3 color indicator tested color indicated, bromothymol blue at 0.04 gram per liter is the most sensitive strain, is the most sensitive indicator. It's a give clear turn in the medium color from green to yellow. The minimal bacterium inoculum is between 10 to 7 to 10 to 8 CFU per milliliters, and the response time is between 8 hours from the most loaded medium to 10 hours for the least medium loaded medium. When we test the most positive sample, the most positive meat juice with our medium inoculated with by Micrococcus luteus at the minimal charge, we constate that the color of the medium change immediately. This is explained by the acidity of the meat juice. When we neutralize this sample, we have the color change, but after incubation. This is due to the multiplication of the meat flora, which acidifies the medium. So the inhibitory effect of our sample appears when we eliminate the flora, the meat flora, by microfiltration. We don't have a change of the color of medium even from an incubation time of 10 hours. So we can summarize the optimal conditions for the tube method. The principal problem in our tube method here is the expensive microfiltration method, which so we propose to replace this method by the introduction of an inhibitor agent, which is NaCl. So we have optimized the concentration of NaCl and the color indicated concentration, the medium charge in the new conditions, and the volume of the sample. The color, the optimal concentration of the color indicator is 0.041 gram per liters. It permits to have a good growth of the sensitive strain with a clear change in the medium color. When we all concentration or investigated concentration of NaCl permits to have a good growth of Micrococcus luteus, and we have an inhibition of the growth of meat juice flora from a concentration of 14 grams per liters. So we have retained in a concentration of 50 grams per liters as an optimum. When we combine the two factors, NaCl concentration and bromothymol concentration, we constate that the optimal concentration are well chosen. So it permits an inhibition, total inhibition of meat juice with a good growth of Micrococcus luteus. The charge of the medium in Micrococcus luteus was also optimized. We have a change of the color of the medium when we from the load medium from a load medium ranging from 10 to 7 to 10 to 10 CFU per milliliters. For an incubation time of 3 hours for the least loaded medium to 30 minutes for the most loaded medium. The volume of the meat juice to be placed in the surface is optimized.
Can you go directly to the conclusion, please?
Il me reste 2 diapos, c'est tout.
Hurry.
We have optimized the volume of our sample. So the most for 12 negative samples and 14 positive samples. The most result was obtained with a charge of the medium of 10 to 9. We have obtained 9 negative samples and 14 positive samples, with an incubation time of 2 hours to 2 hours 13 minutes. For a conclusion, a new alternative screening method, sensitive and adapted for our economic means, has been developed for these optimal conditions. A validation on a large sample with a real economic estimate is suitable to prove its application. Thank you for your attention.